Welcome back everyone. So today the
Facade
design pattern. So it's a strange pattern because for me it's most like a common sense pattern. It's like you probably do it without noticing. So the gist of it is you encapsulate complexity into a neat and narrow interface, essentially. So just before we start, I have a question for you. So what's the design pattern you use the most in your either job or on the side? Let me know in the comments, or maybe it's a design pattern we already seen. Alright, so for the facade pattern, so it's gonna be a pretty classic video, so I'll show you some Go example of course, then pros and cons, we discuss that design pattern in details, and then I'll provide you a link to the code if you want to play with the code as usual. So stay until the end and you'll have the snippet. Alright. As usual, if you enjoy this kind of content or you want more of it, please support the channel, like and subscribe. It's free. I think it's free. It's still free. Yeah, and thank you very much for viewing and supporting, and let me know if you have any question. Of course, I'm doing my best to answer to your request. Alright, so hope you enjoyed the video and happy coding. Okay, so here I have a package called Facade with an init and empty main program as usual. So I start by just creating a subfolder called phone numbers. So my goal is to create a complex infrastructure with a lot of validators and checker for phone number, and I'll see how you can use the facade pattern to hide those complexity. Okay, so the first one is just a simple length check on a phone number. So a phone number is not like an infinite length, so for the UK, for instance, it's like 10 digits. So we can write a simple validation checkpoint. So here, if I create a struct, attach a method to it, so it's taking a number and just return a boolean. So simply if the length of the number is not equal to the standard length, so we can define standard length as a field, as an int in length checker struct. So then it's like modular. So then we can say if it's different from that standard length, then it's not valid. So we can return false, and otherwise it's all good, and we can return true. So nothing complex here, but we will add more checkers. And so as usual, I like to test things as I go. So here I just use id shortcut to build a constructor. We can make standard length as private because there's no need to be public, and let's try that in the main program. So here I'm gonna create another layer, and you'll understand why in a bit. So if we simply create a subfolder called phone number and create service in it, just a simple struct which will invoke the validators. So here, if I just create a function, method function call process, then we can send a number, which is a string, and then we can wire our first length checker. So we need to declare it in the field, in the struct as a field. So private field called length checker. We can simply call it length checker. Just note here that I'm not using interface, but you should use interface here. But just for the simplicity, we will go with a plain implementation. Okay, so we just invoke our isValid method that we just created a few minutes ago, and then we can print the result. Okay, so then here I need a service, and a service will need a checker. So if I just do step by step, so here, because it's private here, I will just provide a constructor. It's quite seamless with my ID. So here we can say new service, and then I need a length checker. So it's fine. We created did we create a constructor? Maybe not. No. We did. Okay, so that's fine. Alright, so then we can use that constructor here. If I just replace the bare struct constructor, and then I can put 10 as standard length for a UK number, for instance. Okay, so then we can inject that into the service. So you can see it's like so the constructor is returning a pointer, but the service require a non-pointer, so I'm dereferencing there in the constructor. Okay, so then we have our service, and we can finally invoke dot process on it, and we can try that. So it's compiling. So +123 is only 4 characters, so we are expecting it to fail. Still compiling. Now it's running. There you go, so false. So then if I randomly type 10 digits, and we try that, so that's 5 and that's 5, so you can see true, so it's all working as intended. Excellent. So let's keep adding some validators and some checker to illustrate that facade pattern. So here I'm creating a prefix validator. So we will just check that the beginning of the number is a valid font number. So it can be either plus, or it can be either 0, 0. So 0, 0 is the equivalent of plus, and vice versa. Okay, so I just create a struct here, and then method here. Struct method, so same signature as the length checker is valid. So we will just send number and then returning a boolean. So nothing complicated so far. So that's the opportunity for me to show you the string library, the inbuilt string library. So if you type strings dot, you can check that a string has a prefix, the prefix you want. So the first argument is the string you want to check against, and then the second argument is the prefix you want to try to match. So it's quite simple. It returns a boolean. Okay, so I said earlier that we want to check if it's 0, 0 or plus. So let's create slice of string with valid prefixes. So plus is 1, and then 0, 0, 0 is 1. Okay, so then we loop through that slice, so valid prefixes. So then a for loop, sorry, a range loop. So then for each prefix, we will use that strings library. So if it has one of the prefix, we can return true, which means it's valid, and then it will act as a early return basically. Okay, so now we can just include that validator in our service. So here we can put OK prefix, then service we need to add it in the struct. So prefix validator, and then added it. Again, here I'm not using interfaces, but you should use interface, but it's just for the illustration of that facade pattern. So okay, and then we can just log that result. Okay, so far so good. So then again, little wiring exercise. I'm just regenerating the constructor, and I will provide a constructor for the prefix validator. So here, there you go. So then back to the main, you can see the constructor is no longer valid, so we need to provide a prefix constructor like that. You could have parameterized the plus and 0 in the constructor, so then you can accept multiple formats. That's an option, but here I went a little bit quick. Okay, so if we run that, you can see that it's true and true. If I just remove the plus, it should be false. It's compiling and running false. I remove the plus, so the length is wrong as well, so you have double false. Okay, so then let's carry on. Let's add more complexity, and let's add a last checker. So we will check the country code. So for the UK, it's 44. So that time we're gonna include the country code as a parameter of the struct, same as we did with the number length. So then it's if it's the US or if it's another country, it's quite flexible. Okay, so you know the song now, so we will just create a simple signature is valid with the number and then send back a boolean. That. So the number as a string and the result as a boolean. So there's a little bit of complexity here because we don't know if it's coming with a plus or a 00, so we need to extract that first, and then we can check the country code with the same method as we used previously, the strings.has prefix. Okay, so there will be a little bit of complexity, just be in the service to trim that down. Okay, so same method, we send the number and we check that the prefix is matching the country code provided in the struct line 6. So if it's matching, that's fine. If it's not matching, we will return false. I could have simplified here and just returned the strings.has prefix. Okay, so same exercise again here. We will mount that validator. Actually, after reflection, we will send the full number here in the country validator, and so then the service is quite lean. So the service is just mounting 3 validators and doesn't understand the complexity of each validator. So let's keep it clean. So here we will just use the method called trim prefix from that inbuilt strings library. So let's create a trim function, some clean code to avoid to have a bulky function line 10. So we will call it trim international. So what that function will do is just removing plus or 00. So it's very similar to that code, so we will just use it. There you go. So valid prefixes, and then if I do a range on it, if the prefix is found, then we will trim the string and send it back. Or otherwise, it shouldn't happen, because the way it's mounted in the service, you should always have a plus or the 0, but we want to cater for that case. So if it has the prefix, we trim like that. And else we can simply just return the number, and obviously the country code should be wrong, but in real life you probably want to fail that earlier and put some gatekeeper. Okay, so the number coming back, if we trim the international prefix, the number coming back can be called national number, for instance. So and then that's the national number we send to the has prefix checker. Okay, so I just created a constructor, and then we will mount that into the service. Alright, so you can see that our service, which is performing a bunch of validation, is getting fairly complex now, and there's even hidden complexity in those validators themselves. So you can see how this facade pattern is starting to make sense now. So there you go, I just send the number to our third validator and just printing back the result. So if we try that, so I will have to go to the main, then create that country code validator, not that struct, but the constructor, yeah, exactly. And then let's just try 44, the UK country code. Okay, so if we try that, so it's gonna be probably triple falses, because it's not the current length, it doesn't start with plus, and it doesn't start with plus 44. So we add back plus and 44. There you go, true. So all work as intended. And if we try that with 0044, but still keeping a length of 10, you can see that triple true, so it's working as intended. Alright, so where is the facade actually? So the facade is the service. So it's a facade to validate a number. The business logic of that service is to validate a number and hide the complexity of each validators. So this is your design pattern essentially. So let's refactor slightly. So if we change the function name process to isValidNumber and then create an interface, validator service, this is what the service was really. So then you have validator service as interface and then service as implementation. So then we can try to build a consumer of that interface, and you will understand why the facade pattern is useful. So there we can create a consumer. So that consumer will consume the validator. So the service here is called consumer, and it has a validator, but the validator here is the interface, that interface we just created. Okay, so if you want to, if we just create a function on that consumer, like process as we called it for the service, so then because we have a validator interface, we do know that the method, so on the consumer.validator, we do know that we have isValidNumber, and then we can invoke it. So from the consumer's perspective, you comply to that interface, and the implementation will hide all the complexity, basically. That's the beauty of that pattern. So then you can reason easily on your consumer, and you can test in isolation as well. Okay, so then I just want to make sure everything works as intended. So let's just create a constructor for that validator. And you can even hide the complexity of the construction here if you want. So a consumer just need a validator, and you can hide which implementation is used. There you go. So I just lifted the code from the main here, and then here I just need a consumer. So phone number, then new consumer. There you go. We can assign that to a variable called consumer, and then consumer, and simply process here. There you go. So you can see how simple is the building and the consumption on the main and the consumer. Here, let's just put our logs a little bit nicer. So the first one was the length. Second one was the prefix. And lastly, it was the country code. Okay, so if we run that after the refactoring, it should all be nice. Okay, so I forgot to put a space or a colon. So if I go back to the service, I can add a space. And there you go. Length is valid, prefix is valid, and country code is valid. There you go. So this is your facade pattern, essentially. All right, some pros and cons discussion on that facade design pattern. So the pros to start with. So clean code, yeah. So obviously, because you're shifting complexity and trying to follow solid principle and having really narrow interfaces and hiding complexity, your code will obviously be neater and cleaner. You probably already use that facade pattern without noticing, probably. Second one, obviously, when things are so much isolated and broken down, it's way much more easy to test. Like you saw from the consumer point of view, is like it just has to test that interface, so it's easily mockable, and your test suite is greatly improved, so then you can extend and scale easily your software. I already said it, but obviously that design pattern was the intent of that one is to hide, like a facade is like a shield somehow. It's like a synonym for a shield, so you're shielding the complexity behind an interface, basically. You can think it about an API level or libraries when you design a facade pattern. So you want to be easy to be consumed by an external third party or an external party, basically. So it pushes you to think what's a good name, what's the correct level of abstraction, what's the correct arguments to send into your facade interface, basically. That's a good tip. That's a general tip, actually. When you design a module, think it as a library or an API. Cons, keep your solid principles in mind. So if your interface facade starts doing a billion of things, it's probably gonna not be a good idea for the single principle. So keep that in mind. And a bit of a repetition, but if your facade is gigantic, that smelly code, basically, it means that from the point of view of your consumer, it's easy to see what's going on, but if behind the scene it's extremely complex, and as soon as you change one component of your interface, of your facade, it breaks, it won't be really resilient software basically. Okay, so as promised, here is the GitHub link for the code you just saw, so hope it's useful. I repeat myself a lot, but just try it by yourself, try to understand how it works. If you need to see or copy paste the code I've written, that's totally fine, but really try to do it by yourself first. Okay, massive thank you for all of you who reached the end of that video. So hope you enjoyed it, hope you learned something, and happy coding. See ya next week.